Good morning, everybody. Today I'll discuss the determination of charge of an electron by Millikan oil drop method. So the experimental setup is like this. Okay, it consists of two optically plane parallel plates made of brass separated by insulating rods of glass. Okay, the lower plate is earthed and the upper plate is connected to the positive terminal of the high tension battery. The high tension battery is around 1000 volts is used in this experiment. So this observation chamber is enclosed in a bigger chamber C, which is circulated by a constant oil bath, constant temperature oil bath. The temperature has to be kept constant because the oil is used in this experiment and the density of the oil is directly depending on the temperature. So in order to maintain the density same, the temperature must be maintained constant. So the oil bath used for maintaining a constant temperature. A heavy non-volatile liquid or oil is sprayed using an atomizer D. The fine droplets are going to enter between the space between the plates here through this pinhole H. So while they entering into the space, the drops may pick up few charges due to the frictional force between the nozzle of the atomizer. Okay, and when the air between the plates is irradiated with the X-rays, the X-rays will ionize this air, then the drop may pick up additional charges. Okay, the drop is observed by making the light to illuminate with the help of an arc lamp here, and the movement of the drop can be observed with the help of a short focused telescope which is fitted with a millimeter scale. Okay, so this is all about the experimental explanation or the construction of the apparatus. Now we shall move on to the theory of the experiment. That is, we have to obtain an expression for charge of the electron, that is E value we have to obtain mathematically. So for that we have to consider a single drop into account for our observation. When the single drop is entered into the observed or entered or observed with the telescope here, the drop starts descending due to the force of gravity. Not only the force of gravity is acting on the drop, but also since the air is viscous, so the coefficient of viscosity is also acting, or the viscous force is acting on the drop, which opposes the motion of the drop. So two type of forces are acting on the drop here. One is due to the gravity, it is making the drop to move in a downward direction. The another force is viscous force, which is making the drop to move in a upward direction. In equilibrium, that is when these two forces are equal, the drop starts moving with a constant velocity. That velocity we call it as a terminal velocity. This terminal velocity can be measured using a stopwatch. So the velocity can be calculated using a basic formula, that is velocity is equal to distance by time taken. The distance between the plates is known. The time we can measure it with the stopwatch here. By knowing the distance and the time, we can calculate the terminal velocity attained by the drop in this experiment. To begin with, the plates are brought in contact with each other so that no electric field is acting on the drop here. Then applying a Stokes law, we can write the forces can be equated here. That is, this is the force due to the gravity, force experienced by the drop due to the gravity. So this is the force experienced by the drop due to viscous drag. In equilibrium, these two can be equated. Let me call this equation number 1, where m is the mass of the drop, g is the acceleration due to gravity, eta is the coefficient of viscosity of the air medium, and a is the radius of the drop, v the terminal velocity. In this experiment, mass cannot be measured directly as well as the radius of the drop cannot be measured directly here. So, we can make use of theoretical formula for the calculation of mass of the drop and the radius of the drop. So, for calculating mass of the drop, we can make use of the basic formula density is equal to mass per volume or mass per unit volume. Therefore, to calculate a mass, we can take volume into density here. So, the volume of the drop, we have written it as 4 by 3 pi a cube because the drop is imagined to be, it is in a spherical shape. So, the volume of the sphere is 4 by 3 pi a cube where a is the radius of the drop into density is nothing but a rho minus sigma is taken where rho is the density of the uh, liquid we can say and density that is sigma is the density of the air medium. So the rho minus sigma is nothing but a relative density of the medium because the two liquids are two viscous mediums are involved in the experiment. So relative velocity has to be taken. G is retained as it is equated to the viscous force here. So from this equation, we can calculate the radius of the drop. 1a gets cancels with 1a of the left hand side. Therefore, a is equal to under root, we will get 9 eta v divided by 2 into rho minus sigma into g. Therefore, the effective, substituting this value of radius in the mass, will get a effective mass of the drop. Here is the mass formula. So, volume into density. Substitute this value in this equation. We'll get the effective mass as this one. Let me call this equation number 2 and this equation we are using in the end of the calculation. Okay. So, now let us apply an electric field to the upper plate, that is positive potential is connected here. Once the potential difference is maintained between the plates, the drop starts moving in a upward direction with a constant velocity v1. Okay. So if n1e is the number of charges on the drop, and remember the charges are here because of the frictional force due to the nozzle of the atomizer and the oil here. So the drop has acquired a few charges in the beginning itself. So if n1 is the number of charges accumulated on the drop, then the net charge on the drop is n1e. Then the net force acting on the drop due to the electric field is given by the expression E into n1 into capital E into n1 into small e, where capital E is the strength of the electric field. n1e is the total number of charges on the drop. Okay. Therefore, the resultant upward force on the drop is equal to en1e minus mg. Again, why we have taken minus mg here is the force experienced by the drop due to the electric field is acting in an upward direction, whereas the force due to gravity is acting in the downward direction. Therefore, the resultant force, we can write it as this quantity minus mg. Okay. According to the Stokes theorem, again we can equate this to the viscous force with the velocity v1 here. Call it equation number 3. Dividing this equation by equation 1 once again I have mentioned here, dividing these two equations, we'll get this expression. Okay. So after doing a calculation, en1e by mg minus mg by mg is nothing but a 1 here, and here all the quantities are same, v1 by v we are going to get here. Okay, as we are interested in calculating the total number of drops on the charges on the drops, retain it in the left hand side and take everything to the right hand side. We will get this expression mg into v1 plus v by e into v. Call it equation number 4. Okay. Now again we have to irradiate the air between the plates with an X-rays. This X-rays incidenting on the air medium will ionizes the air. Thereby the drop is going to pick up a few additional charges. Already N1 charges are there due to the frictional force between the nozzle of the atomizer. Once the air is ionized here, So it is going to, along with those N1 charges, it is going to pick up a additional charges. Let N2 be the additional charges or the new charges accumulated on the drop here. Then the total number of charges is given by N2 into E. So performing the calculation in the same manner, wherever N1 is there, we have to replace it with the N2, and wherever V2 is there, V1 is there, we have to replace it with the V2 here. Then after performing the calculation, we will get the value of N2E here. So N2E can be written as mg into V2 plus V divided by E into V. Taking the difference between these two values, we'll get the expression as this one. So if V2 is greater than V1, then N2 minus N1 will be positive. If V2 is less than V1, N2 minus N1 will be negative. Here both the possibilities are there because when the gas is ionized, we can have both positive charges as well as the negative charges. Thereby, we can have both the possibilities here with plus or minus. So in the final expression, I am going to write it as E is equal to plus or minus of this value. Okay. So while writing a plus or minus, you have to remember why this suddenly plus and minus is existing in the equation, because both type of positive ions are also there, negative ions are also there. So drop may pick up either positive ions or a negative ions. Okay. So Millikan will perform an experiment more than 1,000 times. After performing and recording the readings, he observed that one of the reading for V2 minus V1 is a least value. That means, suppose I'll give you the example here. If you are allowed to take a 500 readings here, among 500 readings, the V2 minus V1, only one value has a least value. The rest of the 499 values will be the multiples of this least value. Okay, so he noticed in his observations that when N2 minus N1 is equal to 1, he observed the V2 minus V1 will be the minimum. So he replaces this equation as, he'll take N2 minus N1 as 1 and V2 minus V1 as the minimum. Finally, he'll get the expression for E as plus or minus mg by EV into V2 minus V1 minimum. So this we have written here. Okay, this is the equation. Now substituting the value of m from equation 2. Okay, equation 2 I have mentioned here once again. So substituting in place of m, this has to be substituted here, so that new equation is in this form. Okay, wherever m is there, just we have substituted this and making some arrangements, rearrangements here, because under root 3 by 2 is there. Okay, so without any power is also, the quantities are outside the without power here, making calculation. Just I will give you the information here. See here, g is to the power 1 is there. In the denominator, g to the power 3 by 2 is there. So 1 minus 3 by 2 is nothing but a minus half. So here we have written in the denominator under root. Okay, got it? Similarly, v is there here in the denominator and v in the numerator under 3 by 2 is there. So 3 by 2 minus 1 will be plus half. Okay, therefore v is retained in the numerator under root here. Similarly, rho minus sigma quantity is existing in both sides here. Rho minus sigma to the power 1, rho minus sigma to the power 3 by 2 is there. 1 minus, as it is in the denominator, 1 minus 3 by 2 is again minus 1 by 2. Therefore, it is retained in the denominator under root here. And 9 eta and 2 is having a power 3 by 2. So, it is separately indicated under 3 by 2. And the rest of the things is retained as it is. So, this will be the final expression for charge of the electron. Now, remember here we have introduced plus or minus here. Taking into consideration positive ion may be accumulated or negative ion may be accumulated here. So the final expression will be E is equal to plus or minus so and so. So after substituting the standard values, Millikan found in his experiment the value of charge of an electron is 1.591 into 10 raised to minus 19 coulomb. Not only Millikan has done the experiment for the determination of E, many other scientists also have done the experiment. So nearly same value all of them have got. So universally accepted value for the charge of electron is 1.602 into 10 raised to minus 19 coulomb. So this is all about the determination of charge of the electron by Millikan oil drop method. Thank you.